Hi, this is a Power Toy model version 0.1. First of all, look at this window. So in our simulation model, we have three kinds of stations. First one is power generation station. Second one are transmission substations. Third ones are distribution substations. And we have four districts in here. So first district has yellow color. Second one has green, third one has cyan, fourth one has violet. In each district, there are 50 users. So look at here, there's 50. So the total number of users is 200 in this case. So when we run the simulation, the power station send power to transmission substations, and transmission substations transmit power to distribution substations. For example, in this case, look at here. This substation need 10 power. Look at 10 here. So in this case, it asks for power to upstream neighbor. If it doesn't have enough power, it asks for power to upstream neighbor, and it asks for power to upstream neighbor. Finally, if it has enough power, it transmits power to downstream neighbor. Finally, power can go to the final destination. So in every tick, the substations, whole substation to like this. So send power to upstream neighbors and downstream neighbors like this. And we have three plot windows. First one for output. So it will show economic output of district 1, 2, 3, 4, and was averaging. And the second one is for unserved power. It will show how much power the users did not use in the last tick, tick. So that the amount of power can be called unserved power. Is ratio, it's percentage. And third one is for at risk. It means how many people are facing risks, or how many substations are facing risks. So this plot will show those things. And we have many input windows and output windows. Look at here. The first of all, seed number. With this seed number, we can get different arrangements of users and substations. Maybe we can change 5. Look at this. We can have a different arrangement. Maybe 1, 2, 3, 4, 5, 6, and we can have different arrangement of users and substations. So maybe we can compare these different different arrangements of users and substations for another study. And so look at here. This is how this power generation. So we can find how to determine the power generation. This is the equation. And the transmission redundancy. So every substation has its own critical load. So it kind of the threshold. So this transmission redundancy is a part of the critical load. This equation shows us how to determine critical load in this for substations. And in this model, we just have exogenous risk. We don't have endogenous risk in this version. Maybe this will be added into the next version. This is probability for exogenous risk. This for memory duration. It means every economic agent has memories for past economic outputs. So in this case, the users has 10. The users remember 10 past economic outputs. And this is a decision rule for majority. If you just want to change something, the system require majority. So this is a decision rule. And this recovery time. It means when the substation failed, it needs time 7 recovery time to be normal. And this improved cost means if economic agents pay this improved cost, the recovery can get faster than others. But even though maybe some economic agents spends this improved cost, these payments may not cause faster recovery, because decision rule is majority. So for the fast recovery require majority of users' money, users' cost. So the paid economic agent can tolerate the no change situation for 3 times, but after this tolerance time, they can move to another district. And look at this. This output window shows us how many people in each district, and this is the ratio of upper class in district 1, 2, 3, 4. So we have 3 classes. So upper class, middle class, the lower class. And these windows show the ratio of upper class people in district 1, 2, 3, 4. And this is frequency of failures in district 1, 2, 3, 4. So this is all these output windows will show the relocation pattern of upper class people. And let's start simulation. Look at here. So the one big issue in this simulation is the difference in time scales. So the user's time scales and the substation's time scale can be different. So for users, 1 tick in 1 tick means the time for the single economic activity, but 1 tick means for substations or power flow systems. For 1 tick means they generate power, send power, ask for power, transmit power, distribute power to users. So this system need to do many things in 1 tick. So to deal with this issue, I use a loop process. So look at this. So just 1 tick, the substations do these activities. So it shows us how much power was transmitted to another substations. And then look at here, this shows the loop process was done successfully. And then let's run. So just one, yeah, here. So there's a risk. The risk is spread, and this risk can cause this failure. The red means failure. So this failure can cause this failure makes some adverse economic impact to users. Look at here, and this unsolved power is increasing in here because of these failures substations and lines. And look at here, this is show us the failures, and then how many people are facing risk in here. So we need to run this simulation. Look at this is a loop process, and then there's a risk spread. Yeah, this is brief explanation for Power Toy model version 0.1. Thank you.